key concept of section 5 is rationalize denominator. So one of our simplifying rules was basically that we can't leave a square root in the denominator, so we need to rationalize it. So whenever there's one single term on bottom, so just a square root of something or fifth root of something or maybe something multiplied by that in front, okay, what we're going to do is really just look at that radicand and say, okay, if this is a square root, then how many more 7s do I need underneath there in order to get that 7 out? Because square root means what times itself, so I really need 2 of whatever's in there, right? So I need 2 square roots of that in order to get that radicand out. So if this is root 7, I want to multiply by another root 7 because then I have a pair and I can take out 7, right? If I have a cube root or a fifth root, that means I need 5 2's, right? Or 5 2's total, so that means I need 4 more. So I need fifth root of 5 more 2's, or 4 more 2's, so that'd be 2 to the fourth. 4 more 2's, right? So then there's 5 total, so then I can take out 2. Now the thing is, if I multiply the bottom by that, I also have to multiply the top by that as well. Okay, and since there's a number on the outside, there's a number on the inside, that 4 just goes on the outside. Same thing here, this 3 is on the outside, this 2 to the fourth is on the inside, so 2 to the fourth is 16, so that stays on the inside, and that 3 that's on the outside stays on the outside. So that's what you do when you have anything square root or any really n root, okay? So whatever you have here, whatever number that's being raised to, you need at least n amount of them, okay? And basically that's what this says here, n minus x. That's how many more I need, okay? So what I need to do if I have more than one term on bottom, so anytime I have 2 terms on bottom, if I have 2 terms on bottom, say this one right here, then I'm going to multiply with that conjugate, okay? So when I multiply the conjugate, the only difference is the second term is opposite sign, right? So instead of adding the 2, I'm subtracting the 2. Okay, and vice versa. Instead of subtracting the 2, I'm adding the 2. Those are conjugates. Now, when we multiply conjugates, it's nice. It looks long like this, but as we can see, as this formula shows us that these two are opposite of each other, so they're going to cancel out, and then you notice that we don't have any more roots anymore. So in our answer, we don't have any more roots. So whenever you multiply by conjugates, say 3 plus root 2 times 3 minus root 2, the middle is going to drop out, so all you have to worry about is first times first and last times last. So 3 times 3 is 9, and a root 2 times a root 2, look, you have a pair, so you pull out a 2, and then positive times a negative. This will always be subtracting here. And then look, I have a regular number out, so I started with roots underneath my denominator maybe, and then I get a whole number in my denominator. So that's the kind of the whole point. So if you have one term, you just do this. If you have 2 terms, you got to multiply by the conjugate. But then again, just like this top one, if I multiply the bottom by the conjugate, then I have to multiply the top by the conjugate of the denominator. So maybe the denominator, or numerator, sorry, is 7. I have to multiply the top by the conjugate of the denominator. So notice that these two are the same, because anything divided by itself is equal to 1. And when I multiply something by 1, I don't change it, right? So the trick is you have to multiply the top and the bottom by the conjugate of the denominator, okay? So that is rationalize the denominator, getting rid of the square root or cube root or any type of root in the denominator.